Okay, so today we're going to talk about composition functions. So how do we evaluate composition functions and create new functions using composition functions concept? We're going to start by just looking at function notation and how to evaluate expressions that are in that form. Then we are going to get into the composition functions. So let's go ahead and do a quick review. All right, so here I have a few examples. So there's two functions. We have f of x, which is x minus 2, and we have g of x, which is x squared minus 3x plus 5. So the first one here is just f of 7. So what this means is that my x value in the function is going to be 7. So anywhere I see an x, I am going to replace it with the 7. So here I have my expression. And so you can see here, I replace the x with the 7, and then you evaluate. So f of 7 equals 5. The next one was f of r. So in this case, instead of a number, we have a letter, but it's exactly the same. We're just going to replace the x with the letter r. Okay, and that gives us a new function with a different variable. All right, next we have an expression in there, x minus 1. That entire x minus 1 is going to replace this original x. So wherever you see the x, it's going to be replaced with anything in the parentheses. So in this case, x minus 1. Then you evaluate, and you get f of x minus 1 equals x minus 3. All right, and then here we have a longer expression, x squared minus 3x plus 5. Again, that entire expression replaces this original x, and then you still have the minus 2 at the end. So you replace it. So this is where the x was. I like putting parentheses where the x is, and then it lets me know that that's where the expression goes, and the minus 2 part. Then we have to combine like terms. I have a positive 5 minus 2 gives me a plus 3. Now, something else to note for this one is that x squared minus 3x plus 5 was the expression for g of x. Okay, so that's going to be important. That is an example of how the composition functions might look. Okay, so kind of keep that in mind, and we'll take a look at that again later. And then a couple other quick examples, this time just using g of x so we can see it with a longer expression. We'll replace the g of x, or do g of 7, replacing the x with the 7. So we have 7 squared minus 3 times 7 plus 5. So notice I put parentheses everywhere there was an x, and inside those parentheses is where I put the 7. And then evaluate. So 7 squared is 49, 3 times 7, 21, 5, add and subtract, and we get g of 7 is 33. Do the same thing with the r. When it's a variable, a single variable, it just changes the variable in the expression. This time we're going to do the x minus 2. Now note here, x minus 2 was the f of x expression. So we're going to be plugging that into the g of x expression. So x minus 2 goes where this x is to become x minus 2 squared minus 3, and then plug it into here. So we'll have an x minus 2 there. You'll have to distribute the 3 and a plus 5. So it would look like this. X minus 2 squared minus 3 times the quantity x minus 2 plus 5. And then evaluate. Now this one you have to be careful with whenever you square something. Remember what it means to square something. Multiply it by itself. And then you have to do the FOIL process and distributive property in the middle. And we get x squared minus 4x plus 4 for the first part. Distribute the minus 3. You get negative 3x plus 6. Remember there was a minus in front of the 3, so you have to take the minus with the 3 when you distribute. And the plus 5 at the end. And then combine like terms, we get x squared minus 7x plus 15. So we created a new function equation here. So let's talk about what a composition function would look like notation-wise. Okay. So the definition of a composition of functions, g with a function f, is this expression. So the h of x is just saying we're creating a new function that equals the composition of g of f of x. So the f of x was one of the functions, g was the other function, and this means I'm putting the f function inside the g function, just like we did on the previous slide with those longer expressions. Okay, and then that creates a new function, which we could call h of x. The h, the g, and the f are just arbitrary. It's like using variables. We tend to use x a lot, but you could use other variables. Here we could use other notation. These are the most common, h, g, and f. So some other notation, we use a circle, a small circle. So like when we multiply, we use a dot. When we're talking about compositions, it's an open circle, small open circle in the middle. So if I do g of x of f of x, this means that the f of x goes inside the g of x. Whatever comes second, you put inside whatever was first. So if I have f of x with the composition of g of x, the g of x, because it's second, goes inside the f of x. So it would look like this, f of g of x. This is another way to write it where the x would be separate. So g composed with f. This again, f is second, so the f means that it goes inside the g function. So you have f of x and it goes inside the g function. And one important thing to note in general, g of f of x does not equal f of g of x. These are not the same things. We can go back to the previous slide and see that we got two different expressions. Let's just do that real quick. So here I had the g of x expression inside the f of x, and I got this quadratic, x squared minus 3x plus 3. Here I had the f of x inside the g of x, and I got x squared minus 7x plus 15. These are two different equations. So when the order in which you do the compositions is very important because they will not be the same. Now there is a special case where they do sometimes come out to be the same, but we're going to talk about that in the next lesson. Okay, and again, that's a special case. So when it happens, it means something specific. All right, let's actually do some problems that look like that. So here I have f of x equals 6x squared minus 2 and g of x equals 4x plus 5. And then we're going to find each of the following. So here I have f of g of x. So that means I'm going to replace the g of x expression inside the f of x. Okay, so I'm looking for the g of x, and I'm going to put it inside the f of x. So there's the f of x. And then in blue, I'm going to replace the x here with the g of x expression. So I put the g of x inside the f of x, and the g of x where the x was. Okay, and now we evaluate. Again, when you evaluate, you're only evaluating the right-hand side. Over here on the left where the 4 of x plus 5 is inside the parentheses next to the f, that just means this is the expression that we're plugging into the equation. So you don't do anything with it. It's just telling you this is what we're plugging in. So then on the right-hand side, you actually evaluate. Remember what it means to square something. Multiply it by itself. And then you can use the FOIL process. Combine like terms. So that would be the 20x and the 20x. So we combine that. And then distribute your 6. And again, combine like terms here at the end, the 150 minus 2. So we get 96x squared plus 240x plus 148. Okay, so that is f of g of x. Here I have g of f of n. So the first thing I want to do is plug the n into the f function. Okay, so this is what it looks like. I just did it another way. We're going to do the n in the f function first, so that the g composed with f of n means g of f of n. So the n has to go into the f function, so I do that first. Then I plug the f function into the g function because it's inside the parentheses. That's what it's doing. So since the f of n is inside the parentheses here, I put it inside the parentheses there. And then I put it wherever I see an x in the g expression. Then evaluate. So I distribute the 4, combine like terms at the end. -8 plus 5 gives me -3. So this is our equation. We have another one down here. Let me just take a quick look. Oh, So just real quick, you can plug an expression into itself. Okay, so g of x is 4x plus 5. So I put that in the parentheses here. And then I put it into the f function again. So I put 4x plus 5 into the x spot of 4x plus 5. And then evaluate. And that gives you another new function. So you can compose a function with itself. Okay, just a couple more examples. These examples that we're going to look at next actually have some numbers involved. So to see how to do it with numbers, right now we were still using just variables. Now we're going to throw in some numbers. So f of g of 3. So the first thing you want to do is evaluate the g of 3, which means I'm going to put the 3 into the g function. So you want to do that first. So I have my g of x is 2x plus 3 from up here. And I'm going to plug the 3 into the x spot and then evaluate, right-hand side only. And that gets me g of 3 is 9. Then that goes into the f function. So then I put the 9 into the f function. And then everywhere I see an x in the f function, I'm going to replace it with a 9. And then evaluate. So 9 squared is 81, and then multiply that by 9, and then subtract the 45. Okay, so f of g of 3 equals 684. So evaluate the inside function first, get a number, and then plug it into the outside function to get your final solution. So here we'll do the same thing. This time I just switched them. So g of f of 3. So plug the 3 into the f function this time because that's what's on the inside. Evaluate that. Okay, so 3 squared and then times the extra 9 and then subtract the 15, we get 66. Then you're going to plug the 66 into the g function. Okay, so right here, 66 is plugged into the g function. And then evaluate the right-hand side of that. So 2 times 66 is 132 plus 3, which is 135. So g of f of 3 equals 135. Okay, let's see if I had any, nope, nothing else, that was it. So if you have any questions, please send an email so that we can address those questions. And there will be a handout on composition of functions for your assignment. Okay, so please check your assignment on Google Classroom.